a trig equation here. We're solving between 0 and 2 pi. First things first, let's get rid of these double angle formulae. So it's going to be 2 sine theta cos theta. And then there's various different ways we can write down cos 2 theta. Could write it as cos squared theta minus sine squared theta. The only thing is we're introducing a sine squared. We're not going to have a common factor, so actually it makes sense to substitute in for sine squared plus cos squared is 1. So sine squared is 1 minus cos squared, and we're going to get 2 cos squared theta minus 1. And of course we're still plusing 1. That equals root 6 cos theta. And these two are going to cancel. So that's good. Now we can factorize out that cos theta. So it's going to be cos theta 2 sine theta plus 2 cos theta minus root 6 equals 0. This implies cos theta is equal to 0, or 2 lots of sine theta plus cos theta will equal root 6. Okay, let me deal with the left-hand one. We're simply going to get that theta is pi over 2. That's 90 degrees. Or this one here, which is going to be 2 pi minus pi over 2, which gives us 3 pi over 2. The right-hand one is a little bit trickier to deal with. I think I'm going to first of all write it as sine theta plus cos theta is going to be, well, it's going to be root 6 over root 4, which is actually root 3 over 2. Not the square root of 3 over 2, which is probably where we're headed, but the square root of 3 over 2. Okay, so to deal with this, we need to combine it into a single either sine or cos. So write sine theta plus cos theta is identical to r sine theta plus alpha. We can write it like this because we can expand this using our addition formulae to give sine theta cos alpha plus r sine alpha cos theta. And this is good because now we can compare coefficients. We've got sine theta here and sine theta here. So it must be that r cos alpha is equal to 1, and cos theta here, cos theta here, so it must be that r sine alpha is also equal to 1. Divide the bottom by the top will leave us with tan alpha equals 1 because the r's cancel and 1 divided by 1 is just 1. Therefore alpha is simply pi over 4. That's the smallest acute angle we can get. And we can square and add them. R squared sine squared alpha plus cos squared alpha will equal 2. This is just 1, so we get that r is root 2. Actually, I'm just going to come over here. So the whole purpose of that is that we can now rewrite sine theta plus cos theta as root 2 sine theta plus pi over 4 equals root 3 over 2. And if we divide through by root 2, then we can write this as root 3 over root 2, divide by root 2 again, we're going to get root 3 over 2. Okay, and this is a number that you should be familiar with. So sine 30 degrees is a half, and sine 60 degrees is root 3 over 2, or equivalently sine pi over 3 is root 3 over 2. And therefore theta plus pi over 4 will equal pi over 3. That's here, or it'll be 2 pi over 3 due to symmetry. That means that theta is going to be 4 pi over 12 minus 3 pi over 12 if I put them over a common denominator, which gives me pi over 12. Or theta is 8 pi over 12 minus 3 pi over 12, which is 5 pi over 12. And we've got all our solutions. So overall, theta is pi over 12, 5 pi over 12, pi over 2, or 3 pi over 2. Remember, those solutions were found previously, so we need to include them in the final answer. So quite a lot of trig things tested, double angle formulae, factorizing it, and then using this form of trig to combine a sine and a cos added together, and finally solving that and bringing it all together. Okay, well done.